In this lesson, we are going to learn how to find poles and zeros of a transfer function. Firstly, what is a transfer function? A transfer function is a function that shows the relationship between the output and input of a control system. Okay, it's shown here. Normally, a transfer function is written in the Laplace domain. Okay, it's a function of S, and S is the complex frequency. Okay, now let's look at the transfer function here. In general, any transfer function can be written in this form. The k is the gain, and here we have a numerator and a denominator, and both are polynomials of function of S. The pole and zero refers to, when we say zero, it means all the values of S in which the HS becomes zero. Okay, and poles means all the values of S in this function for which the HS becomes infinity. How to find these values? The easiest way, we look at an example. Okay, this is an example. Here we have a transfer function. We can see there's a polynomial. This is the numerator and this is the denominator. First, let's find the zero. To find the zero, we take every term in the numerator. Okay, every term in the numerator, and we equate it to 0. Then we find the value of S. Okay, first is S plus 1. So we find S plus 1 equals to 0, which means S equals to minus 1. Then the second term is S plus 2. Same thing, and we get S equals to minus 2. So these are the two zeros. Second step, we want to find the poles. We set each term in the denominator to be 0, which means every term at the bottom here, we set it to 0. Okay, here we have S plus 3 equals to 0. If we solve this, we get S equals to minus 3. And the second term here is this one. This is a quadratic term. So we set the whole term equals to 0. And if we solve for this, we'll get these two answers. These are complex numbers, -1 plus j1 and -1 minus j1. How to solve for this? The easiest way is you can use your calculator. In all your calculators, you can directly solve this. I've given an example here. You can check in the internet for your own model how to solve. Okay. Now we have found the zeros and poles. The following step is to plot the pole zero diagram. Okay, pole zero diagram is, we just put like a normal plot. Your y-axis, in the y-axis we write j omega, and then in the x-axis we put this symbol, sigma. It's called a sigma symbol. Just put this symbol, and then now we are going to plot the zeros and poles. For the zeros, we'll use the symbol 0, and for the pole, we'll use x. Okay, let's see one by one. Our first 0 is -1, so we go to S -1 here, we put a circle. Okay, because it's a 0. And another 0 is -2, so we go to -2 and we put a circle. Then for the pole, we will use x. So our pole is -3. We go to -3 and we put a x here. Okay. Here are complex numbers. How to plot a complex number? This is a complex plane. This part is real. This is imaginary. So we have to see here. -1 plus 1j. So you go to -1. -1 is real. Real is the x-axis, -1. And your imaginary is 1j, which is your y-axis, 1. So this is where this one, just put an x here. And for this, -1 minus 1j. So -1 is the real axis. This -1 is the imaginary. And we put a x here. So this is how we plot the poles and zeros. Okay. That's all. That's all to plot poles and zeros. Thank you.